Okay, I think we can begin now. The rest will join as we go. So, hi everyone. Thank you again for your attendance. Today we have Liran, and he will be taking us through Node.js Security. He has amazing personalities, and apparently he's an expert in JavaScript. So, I'm excited to hear what he has to say, and hope you enjoy the session too. You can begin.
Thanks, Maria. Hey, everyone. Thank you for joining. This is exciting, meeting everyone, having you here. Feel free if you wanted to kind of like unmute and share the webcam and ask questions all across, the session. This is really about us engaging and learning. So this is an interactive session, and hopefully you can play along with some of the examples and the questions. But really, this is open, safe space. Security is also new to many people, so don't be shy. Just raising a hand, asking questions, and just taking part. So with that said, I guess we'll get started. So this is a session which I was chatting with Maria and Eve, and we're thinking about let's do a Node.js security kind of topic, which cybersecurity is in general very interesting, just in terms of this is a very trendy kind of space right now. You're probably hearing a lot of things in the news, probably also unrelated to any ecosystems you're on. Java, JavaScript, others, there's always news, headlines, data breaches, security incidents, and stuff like that. And the mission that you have as well to just get into a career in cybersecurity is also super important and relevant for the future of technology. So I'm super excited to be here and super excited to also touch base specifically on this topic. Introducing myself shortly, my name is Lirantal. I'm a developer advocate at Snyk. Snyk does a lot of security tooling for developers. We've got this whole platform, and there's a free tier. You can get started really easily and quickly. But really what it does is all about helping you as developers, myself included, to basically be able to solve security issues without having very mastermind kind of expertise in security. And it does so because it knows and understands that developers, like all of us here, are kind of the bottleneck and the important glue that actually needs to push out those fixes. There's a ton of automation and really cool stuff that really speaks to developers. So that's what Snyk does, and I'll show you a couple of things around that and how you can work with that if you wanted to. But really, this is a lot of stories that we're going to see here in terms of what was happening on the JavaScript and Node.js ecosystems recently. So talking about that, I'm also part of doing a lot of work on the OpenJS Foundation and Node.js project. So also, if you wanted to take part in open source and join one of those working groups and initiatives, please reach out. I'll be happy to connect you. I've done this before already. People who are, taking a part in public, big open source projects, I'd love to just mentor and help you out. So, DM me afterwards and we can chat. So I've been doing a lot of those kind of things. I do not want to get into all of them right now. There's, a bunch of stuff on the slides, and I want to slide over to talking about, open source and JavaScript and Node.js security, I guess. So when we talk about security, I guess one of those, I'll call them topics that we cannot avoid from hearing about in the news is the source of supply chain security, right? What is supply chain? What is supply chain security? What is software supply chain? And how does open source software relate to all of those kind of things? We won't have time to touch on all of this because I also wanted this session to be somewhat hands-on and live hacking and stuff like that to give you the experience of what it's like. But just giving you a brief of what it might look like. So when you're doing npm install, for example, from the CLI, wanting to install maybe the CoffeeScript npm package, the question is really, are you installing the exact same package as it was written and not maybe a typo of a package that someone else had put into the registry, and this one is actually malicious, so maybe be careful and not install this specific npm package. And so this is kind of taking us towards the beginning of what is supply chain security. It's basically all of those maybe packages that we're bringing onto our projects that, well, may have issues. Let's call it like that. And so this is one of those issues. The other one is maybe malicious packages, not by a typo, but they have been specifically created as a malicious package that you might install because you saw someone putting it on like a web forum or like Reddit thread, or like, I don't know, you've heard about it, somewhere and decided to install it for some reason. You've put your trust, kind of like misguided in some other place where you shouldn't have, and installed a malicious package, and that existed on the registry. Other cases are, of course, the fact that myself and other maintainers may not use good hygiene of application of account security. And so account security is anything of like takeover attacks, which are maybe because I used a very short password, a very kind of like easy to guess password. Maybe I did not enable two-factor authentication, all of those kind of like, low low quality account settings. And so all of them may lead to the fact that, yes, maybe I own a legitimate package like any of those in this list, but if someone can actually take over my account, they can release new versions of malicious, they would be malicious, in my name. And that's another problem. Of all of those are kind of like examples of supply chain security issues that we've seen in open source. All of these stories are, of course, true. In this case, there's like asterisk around like React and something else that did not exactly was malicious, but there was a different issue there. If you're interested in that, just reach out and I'll explain a little bit more in details what happened. But all of those stories are really true and really happened. And so the supply chain security is that it's more than that. It's actually the CI systems that we're using and all of those things that make up, I guess, this software development lifecycle, how we build software, our IDEs, if they are compromised, and all of those stories also like really happened. So today we're going to just specifically focus, even though the problem space and the attack surface is a lot bigger, we're going to focus specifically on Node.js related security due to open source dependencies being, vulnerable. So we're going to hack an application, and we are going to use several open source dependencies that may have vulnerabilities in them. We'll see how it happens and how it actually impacts the application. It's a simple use case, as you can see here in this code base, where I'm using Markdown as you can Google it right now, and for NPM or something like that, what marked is. You see it has quite a few millions of downloads. So it's pretty popular, yet some versions of it do have vulnerabilities in it. So if you're not using the correct, or I will say the up-to-date and safe and secure version, you are potentially vulnerable to vulnerabilities that I'll show you how they work in this session. But even though we talked a little bit, we dove straight into kind of like code and security vulnerabilities and issues and supply chain security. Sorry about that. But I kind of want to take a moment and say, if you are spending your precious time here with me, with each other, we're learning together. It kind of means that you probably care about software security, and pretty sure you also care about open source software security. And so thank you for that, and I really, really appreciate it, and thank you for your time spending with us. As you probably know, working within the cybersecurity domain, this is a really tough and challenging domain, because it is not something that we are usually taught of in terms of the computer science degree or high school kind of like computer related skills, right? Like we just pick it up. So there are a ton of resources like OWASP and others. I'll give you a few that we have also. It's free and very accessible to everyone to just learn and skill up. But generally, this is a problem, right? Application security, information security is hard. It's not something we have like an official kind of like as developers. I'm saying, right? Like as developers, we graduate, we do not have all the skills to create super secure software, and that's a problem. And I want to show you why this is like such an extreme case of application security being such a problem. So here's, if you've done a little bit of Node.js, this might be familiar. If not, I'll extend in a second for a second what this actually means. So this is a function signature of an Express web application middleware function. Essentially what it means is that this little code base exposes a function called available as a route, as an exported named function admin. And what it does is it receives request and response as objects into the function variables, and it has this user.find function call inside in the function body. Actually, we can assume, right? We can probably guess this is some database call going outside looking for users. We can see it actually takes an object with username and password and asking, I guess, the database for a match. So these username and password are actually coming from the request itself, like from the HTTP request. So we can see request.body, username, password, all of those things. Looks like a login function. I'll try to monitor the chat because I want to ask some questions here, and feel free to just put them there. But if you kind of like already seeing or already saw what was the, what is the potential dangerous issue here, please let me know. I'll try to monitor the chat as I speak. But really, there's an issue here. There's a bunch of stuff. One of the obvious things is probably we can say, hey, this isn't being using a secure password storage mechanism, meaning there's no hash of the password. The clear text password is matched with the clear text version of it, of like what we get from the user to the database. There are potentially other issues here. But let me take you towards another step of like what is actually happening here. Most of Node.js Express web applications have this ability, or like this line of code, whether built in by other middlewares or they, developers just recently added that themselves, of basically saying, well, I want to use the body parser middleware. And that essentially means that if you're using the body parser middleware, then any objects that flow into the request have also that are JSON kind of like encoded. They will also be appearing as JSON objects on the language runtime itself. And so what essentially that means is the following, and this is the vulnerability that actually exists in that code base. It's the fact that the password field actually gets a valid object, JavaScript object, into it as a value if this is something that an attacker sends it from the system, from like the HTTP or request or something like that. And so if I can actually state, for example, a MongoDB operator, because this is what actually happens behind the scene with the user.find, this is a method on the database. And so if I'm actually running this this exact code on my end, and someone sends in this object that says greater than nothing, then essentially MongoDB treats it as an operator that it actually supports, which is, as you can imagine, greater than nothing will probably yield 1 or 2 passwords for a username of like admin or something like that. And this is essentially becoming a NoSQL injection and a NoSQL vulnerability being exploited in our systems. So with that said, there's, I don't know, 5, 6, 7 lines of code here that are, I'm pretty sure people were thinking here, someone should sanitize it, should do, more than a few things of like proactive controls that you have in your disposal as a developer to write secure, bulletproof code as much as you can. Except here's a case for, one project called Rocket Chat where they had a similar issue, right? They had a similar issue where an unauthenticated NoSQL injection happened because one of those code bases uses that users that find one model function call for getting the password policy function. But you could see it actually is trying to use the value for one of those keys in the object that it looks for from the user. So params.token is essentially any value that I control as an attacker, and that actually finds its way in. And that this sort of NoSQL injection is not just about being able to search different records. I could actually create a denial of service on the MongoDB due to specific operators, due to being able to maybe just insert JavaScript and stuff like that. So this is pretty alarming. Hope they fix it, of course, pretty fast, which is, kudos to Rocket Chat project. But it does happen even for projects as big as this with hundreds of millions of downloads and users. So our Node.js surface, got a little bit bigger. We're not going to touch on all of the aspects of, the attack surface and the supply chain security that impacts our application, but we're going to talk about open source dependencies again. And I'm pretty sure people are using here npm install, in your projects, and you are probably getting a little bit frustrated when you install packages and seeing probably a lot of packages that have vulnerabilities in them. Maybe a high number, maybe you're not entirely sure why or what is the aspect and what is the impact on your system. And I'm pretty sure this is a bit daunting. And so we'll learn why it is important, and some things can be ignored, but we need to apply judgment and context. And that is where our job as developers to kind of triage those vulnerabilities in our applications is important. So here's, several inputs. First of all, so these are a few highlights from some of security articles that I've been reading and stuff like that. And you could actually find one highlight here is 61% of packages on NPM, which is now 1.8, almost 1.9 million packages, could be considered abandoned because they haven't released any new version, new release to NPM as a registry in the last 12 months. Now, this is a research that was disclosed back in 2019. And back then, I think it was 800,000. So still about half from what we have today because of the large growth on NPM. But still, that was close to 1 million packages, and more than half of them could potentially be considered abandoned just because they haven't released a new version. The thing is, the more that we get packages into the registry, which makes sense for a lot of people, new versions, new packages, all of those kind of things. There's a lot of open source growth, but there's also a lot of growth and vulnerabilities that we find for all of those packages. So the trend is also high, right? If you've heard the term CVE, right, common vulnerability enumeration, basically the report that gets assigned to vulnerabilities and related to, I would say, a package or a vendor. Those identifiers also grow, and we do find and put a lot there. So what did we have so far? We talked about us, writing our own code, whether that would be that Express web application middleware that could potentially have NoSQL injections in it. We also talked about different cases where I could use an open source package like Mark to basically do Markdown. And the case is really that it's not just my own code, it's actually the entire open source dependencies that are fueling my application, right? Like I could use Fastify as a web application server, could use Type ORM as an ORM, an SQL ORM database abstraction thing, could use LeftPad if I wanted to. There's a bunch of attack surfaces that actually exist there. If I actually look at the repository and what it looks like, and when I scan a repository, and that is kind of like when we import the repository into Snyk, we look at all of those manifest files that are related to the developer scope. And that's actually a lot. That's where we've taken the role of a developer and went into cloud native development. We basically are now in charge of our dependencies. And if you spot a Docker file, there's potentially a Docker file and a Terraform file for Kubernetes and stuff like that. So we've basically done a lot of things. But I want to focus specifically here on dependencies, on my package.json and any dependencies that I have there. So let's imagine we're building an application together. And this is where I kind of need you to, if you want to step in the conversation and play along, please do. So let's take this use case where we want to build this to-do application. We can imagine there's going to be a text box and a button to add, I guess, to-do items into it. So I will have something as simple as that. But I also want to make sure that I actually am able to support Markdown, so I can add links in my to-dos and stuff like that as well. That would be cool. That would be nice. So let's say that I want to do that. I want to add to do she hacks. I have a typo there. I say Kia, but this is really she hacks Kenya. Anyway, so back to the point here. So if I wanted to add something like that, if I wouldn't be able to, if I didn't want to go and use an open source package, I'd need to build a whole parsing, understanding Markdown, translating that to HTML as I want to display it and all of those things. But I don't want to do that. I do not want to write, the wheel from scratch. I do not want to reinvent the wheel. I actually want to use open source packages to do the job, which makes sense. This is why we have repositories and registries like in PMJS, and well, open source is pretty cool. So I went into this thing called the Snyk Advisor, which is a cool free tool that we've built for developers for actually launched today Go, but also existed before NPM and Python, as well as Docker images. So I could go in here, slot in an NPM package name, find it. And if you see for Mark, I actually have 100 of 100 package hold score, which means it's very popular, well-maintained. Looking at the packages, hopefully, the security vulnerabilities, and hopefully I can find that the version that I want to use or are using today does not have an actual vulnerability associated with it directly or indirectly. Once I've made sure of that, I can go and now start thinking, what are the use cases where people would try to maybe abuse this input that I've created, right? It's just simple web page. It's like really vanilla JavaScript. I've just put some marked as like another component into this UI, and that's it. So if I've done that, and I could imagine someone might be adding JavaScript :alert, and they might be trying to trigger some cross-site scripting vulnerabilities, which essentially means they are able to evaluate JavaScript per the person that's now viewing this web page. And if they're able to do that, they could potentially steal your cookies or submit to-dos for you or delete your to-dos. And now you can take and apply this idea of like a simple application of a demo one and to a real world application. And you could imagine that if someone has control of JavaScript onto the web page for you as a user, what happens when that system that you're on is a web application, not of a to-do system, but like of a banking system. I can make transfers in your name. I can click on buttons in your bank account in your name and do all of those kind of things. And that's where things get really scary. So it's not just about having controls of, hey, my cookie is going to be HTTP only and stuff like that. There's other things that could happen that are, pretty bad. So we do not want this to happen. Let's see what marked does to actually mitigate the fact that if you try and inject this kind of JavaScript onto the page, then it won't work. So I want to look at that with you, and we'll learn from that what are the mistakes that may have been done here. Of course, I'm taking like a small pause, methodical pause. If there are any questions, feel free to just jump in. Okay. All right, we're good. Okay. So here's so these are snippets of code from the version of Mark that I'm using in the app that I'll show you, in a few minutes. And let's go through it. Let's see how it tries to mitigate the fact that someone adds JavaScript :alert, and that wouldn't fire. That would actually be blocked. So there's a link function that receives an href not attribute. This is an href variable into the function. What it does with it is it does some kind of sanitization or filtering. It tries to check if it's actually matching, like the start of the string is a JavaScript colon, which makes sense. We could ask a lot of questions like, for example, why is it actually looking for the start of a string and not anywhere? Maybe because JavaScript is allowed to be anywhere else in a URL and stuff like that. So like you could try to think of it and already I think dive into the mind of someone writing proactive controls like this to help like filter those things out and kind of reverse engineer what they were thinking about when they wrote it. So I mean, this if case looks pretty legitimate. There's another case of like VBScript, which you won't get into. It's like the same exact example though. So they've done that. But if I wanted to also kind of like circumvent this, I could use something that it's a technique to basically display variables, not display characters on the DOM on the page without me explicitly writing the variable. And what I mean is I could actually, if I wanted to like tell the browser, hey, draw a colon here. That's what I mean. You should like interpret this as a colon or something like that. I could use something called HTML entities. Those HTML entities are basically telling the browser if I have a specific character that I'm giving it, like it's like just a character code, then the browser, when it says it, it says, hey, I need to like draw a colon or a less than sign or stuff like that. So if I'm able to do those, maybe I'm able to circumvent it. But I'll change slides. I'll dive deeper into the code, and you can see that there's actually another filter there. The other filter says the code URI component unescape href. That unescape href, let's see what that does. So the moment I dive into that function call, unescape href is actually the variable, the href value, so the URL, JavaScript :alert in our example, that would be the payload, passed into the unescape function. The unescape function specifically does this regular expression kind of logic matching, where it tries to see if someone, if someone is trying to escape it, what we were just trying to like attack it, to escape it using those HTML entities. And if so, it filters that away as well. So it kind of so someone who wrote this library had specific built-in mechanism to help defend against someone else exploiting it with cross-site scripting vulnerabilities. I'll stop and see if there's any questions so far. If not, we'll kind of dive into the demos. Let me see the chat. Anything on the chat? All right. Nothing yet. Okay, cool. So let me, so with that said, imagine you're hacking this in. Let's see how this looks like. Okay. I'm going to run my application. No, actually that won't work because I need to run my database first. I'm going to use Docker to run my MongoDB here, and we'll give it a second. Hopefully nothing crashes at this point. And here, let's prepare just running npm run start. While it starts, it's a bit slow, but it does start. I'll start this one as well. And able to connect, yes, 3001 and express it. Okay, so we've got this here. Okay, cool. So we have our web application project here. This is a to-do application, like we said before. And I could add anything here like, oh yeah. Like that, right? But I could also, like we said, I could also like add something like a URL. And I could add any other thing that kind of makes sense. And the reason that I'm able to do that is because if I go back to the code here, my package JSON actually has this, I'll get this a bit bigger, has a version of marked. Okay, it has a lot of vulnerabilities in it because I'm using a plugin that shows me those. But if I wasn't, then you may have not known at all that you're using a version that is vulnerable. But I am using marked for this purpose of demonstration, which with a vulnerable that is vulnerable. And I could see the use cases of marked. I have marked here, and you could see that I've even instantiated it, the marked library, with sanitization enabled. So that means that I'm actually now sanitizing all of those use cases of potentially someone injecting cross-site scripting vulnerabilities. What it means is if someone tries to do something like that, we are hoping that it mitigates the issue, which it does. So like no JavaScript was created on this page, which is good for us. So far, any questions? Looking at the chat. Okay. No, okay. So let's try something else. Let's try to put JavaScript here and see if we're going to get any potential cross-site scripting vulnerabilities. Not really, right? That's kind of what we wanted to test. And we see that this is not vulnerable. Like someone entering any valid to-do item here, potentially from the outside to the system, which we do not control, that doesn't, in this case, result in any bad thing on our system. So that looks okay. Any ideas of what else I could try? Let me post that again. Let me check if there's anything in the chat as well. Oh, awesome. I've basically lost my trackpad right now. Give me a sec. Oh, amazing. No batteries here, just a sec. This is going to be a second until we kind of sort out technical difficulty here. Let's see. Nope, not yet. Try that. Okay, there we go. I have my mouse again. All right, we're good. We're good. We're good here. So let's try something else. Let's say, no, browser don't get stuck. Let's say that it's trying to, someone is actually saying, hey, let me try and replace JavaScript colon with essentially not colon, but I'll represent it in a different way. So I may try just putting here. Let me, okay, this is not responding yet. Let's wait for the browser to get okay. No, not responding. Give it a few more seconds. See if we get the browser back. Okay, we got it. So I will now represent basically colon in a different way. So that I want to represent this as this, which is an HTML entity, and then this, which is another HTML entity. And this specific HTML entity notation really means that it actually is a closing round bracket. And this HTML entity notation, when I add that to the DOM, the browser interprets this and say, hey, I think this, what you actually want to put there is a colon, and that's what it does. It replaces that with a colon. So let's try and put that in and see what happens. Okay, sorry, Zoom screens. Try that again. There we go. So I've put that in, and we can see that, well, nothing really happened in terms of it apparently got filtered and sanitized the way that we were hoping the marked library would actually save us, which is great. But I think there's still an issue there. So if I go and scan this application with Nick, what I'll find is that essentially this is my goof application, that to-do item that I showed you. It has a bunch of different manifests that Snyk picked up, like the Docker file if you're running this as a container and other things. And specifically the package JSON that has issues in it. So if I filter all of the results here, search for marked, and sorry about that. And if I search for marked, you could see that it has regular expression in out service. It has cross-site scripting, like different kind of issues in it. So if it has a cross-site scripting issue, like for example, this one, why were we not able to recreate the exact same exploitation and the vulnerability in the application itself? Like we would expect it to be vulnerable. But the thing is, it is very much vulnerable. All of those vulnerabilities really do apply to our application. But we just haven't used the right recipe in the exploit payload. What that essentially means is, what has been discovered in this vulnerability is, if I add any sort of valid JavaScript statement, like literally the word this, or maybe document, right? Wait, document, there we go. No typos, document, yes. So if I add this, which is a valid JavaScript statement, right? Like you could open console the console on the DevTools and type that in, and you'll get a document for this window or something like that. So this is valid. What happens behind the scenes is this whole thing mitigates and bypasses the sanitization and the filter logic that we've seen were happening with a regular expression catch that was supposed to find this and filter this out in marked. That is because it didn't expect this kind of logic to appear in the regex matching scheme, because there really is no valid HTML entity that after the the number, the 5841, after the digits, it doesn't, nothing else gets added there in terms of like a string. Here, this is what we did, but it has some interesting side effects. So if I now click enter, I hit the return key and I now added this to do item into my application. Now I see that it doesn't break anymore like it did before, but instead I have a valid entry. It's gonna send me to example.com. Let's see. Well, not sending me there. It actually is showing me the alert box that I was trying so hard to enter here, to create a use case of a vulnerability in this application. And this was actually made possible due to the fact that my application, as much as I'm writing maybe secure code, or I may have other protections in place to help me do this, but the sore reality here is libraries here had those vulnerabilities in them, and I was not able to catch up fast enough with those upgrades maybe. So I'm using a vulnerable, outdated version of Marked, even though this is getting downloaded by millions. Doesn't really happen, doesn't really matter to me, that I'm using a vulnerable version. And now I have this vulnerability in my application. So we've seen one use case of where vulnerability could happen in my application. Let me see if there's any stuff if there's any questions, I'll actually like maybe dive into like a different demo here. But if there's anything you kind of want to ask or drill down deeper into, just put it in the chat and I'll kind of try to follow along here. So let's try something else. I'm thinking of what would we want to try? Maybe something server side. Let me open up. So let's try this. Let's try about new is a new page here. Oh, by the way, we are streaming this to several platforms. I think YouTube is one of them. I'm not monitoring that chat. This is only for the chat that's available for SheHacks Kenya community on the Zoom app. So just letting you all know, I'm not ignoring you on the YouTube chat if you're leaving anything there. Okay, so let's try this. Okay, this in our case. Let me see if I have got some stuff working here. Where's my mouse? Okay, cursor found. Let's do this. So, okay, now we have right here. So I have this about new page, which if I'll show you what is the code for it, I think it will make a lot of sense. Let's close this. So this is a simple templating engine called Dust that allows me to basically render pages on the server side and then send that HTML to the site. So you can see that it has some kind of condition here, which is cool that I can do that on the server side, like having those dynamic conditions that get evaluated on the server side. In this case, it's a condition whether device equals desktop. And based on that, it actually draws the font smaller or bigger. So I could actually, this is where it's coming from. If I add something here, like device equals desktop, it's gonna make it, I don't know, I guess small. Let's try mobile. No, device equals desktop. Okay, so mobile was actually the bigger one, and desktop like that, very much hard case or case sensitive is actually what's going to draw it as like a small font. So it shows you how dynamic templates are being evaluated really on the server side here. Let's go back to mobile and try to understand what's going on here. So this condition, like how does that really happen, right? This evaluation of conditional terms. In this case, I'm actually using not just Dust as the open source library here to basically render that page. I'm actually using some Dust related helpers from the community to help me have those kind of like if conditions, like exactly this one, an if condition. And I can put, so this is user input flowing into the condition in terms of like the device there. But generally, this entire statement, the condition, is developer controlled. Like I wrote it as a developer, so nothing there, as you could see, looks like it would be malicious, right? But if that's really flowing into Dust, then the question is, what happens behind the hood with, under the hood with Dust here? So let's go into Dust helpers and see what's going on there. If I go here, this is one of the Dust helpers. Considers like an if function, which is one of the helpers that Dust makes available. There's a context, what is a couple of stuff there. we go. We have condition getting extracted out of this dot helpers kind of function, and flows right into eval. I'm pretty sure folks who are doing JavaScript know that using eval is very dangerous because it allows you to evaluate JavaScript code at runtime. And if user input flows into that, well, no, that could be dangerous. That's not something you really want happening. Except this is something that unless I looked at the source code, I wouldn't really know myself. And you could potentially have millions of lines of source code for all of the libraries and the nested libraries that you're using and importing into the project. So source code reviewing line by line all of your open source dependencies, that doesn't really make sense. Except that I also actually want to trust my libraries. So besides this helper that maybe I hope nothing really bad happens here, but even if it does, I mean, Dust as a library, not the helpers, but Dust, the main library, has some precautions in place by itself to help you mitigate those kind of potential issues. For example, it has this escape HTML function, which you can see it receives s as a variable. It tests if s is a string, and if so, it again tests it for specific stuff, probably for if it has some dangerous characters that it needs to do something with, like clean them up. And if it does, it will actually go and clean them up. So this is essentially doing HTML output encoding, which is if you're doing React or Angular or Vue, like you're like a front-end person, and you are told, those new libraries, those modern Vue libraries are secure kind of like by default. Like if you've heard that, this is what they do, right? They take whatever you feed them into like the JSX or input somewhere else, and they anything dangerous like left brackets, the left angles, the right angle brackets, all of those kind of things, it actually turns them into HTML entities. That's what we've seen and learned before from Arc. So you could see ampersand is being translated into that one, and the less than symbol translated into that one. And this is essentially what is protecting you, because the web page, the DOM, is not actually evaluating this as an actual DOM element, HTML element, but just as a representation of a string, of a text string that needs to look like it has a left angle bracket thing. So looks like it's doing what it should be doing, and I mean, I think it's okay. So let's try a few different things. First of all, I want to copy all of that and take that into my terminal screen here, just so we can see what's happening. First off, this is the Node.js backend of this server. You could see all of our tests here in the request log. So desktop, desktop device, mobile, all of those kind of attempts. I'm going to open another one and let's see what happens when we're sending some requests. So I'm going to do curl HTTP localhost 3001 about new device equals desktop. Okay, so just doing that, let me actually make that a bit bigger so you could see it from like different, watching it from mobile or something as exotic as that, you could see it a bit better. So I've basically sent a request. This is all locally on my machine, but it's still a web HTTP request, getting transmitted from localhost to localhost, showing it that I've basically sent a device equals desktop request, and I got the HTML back, right? If I go back here, you could see this is my before my return keys. I'm going to push this again up, and you could see this is my 2 new requests of probably the one before, and now this is this curl request. So I've done this, and the question is, how do I actually escape from it? So one of the things that I kind of like jump to the end here, as I kind of want to cover a few more resources and leave you with some stuff to think about and potentially some questions. But one of the things that we could figure out is, what if a device is, well, not just equals a desktop string, but what if I could provide several devices? Like, I'll now try and be a bit, smart ass for a second here with the data. I could do, device equals desktop and also device equals mobile, or I can do 2 desktops. I have no idea what that does to the backend as I'm sending those requests. Sorry, as like an adversary. And I have no idea. Like, looks like it works. Like nothing gets messed up, I guess. Like this is okay. Looking back at the server over here, the server logs showing me something is okay. But if you notice something that's different now is now device is not anymore a string, which it was before, but now it's actually an array. That is interesting because if we go back to the code base of Dust, remember when we read it out loud, it said if type of S is a string, then but if it's not a string, if it's an array, then this entire control block that saves us from having basically XSS or anything else just flowing in without getting getting sanitized is returned as is. And that is where the vulnerability exists in Dust as a template engine on my backend of a Node.js service. It is specifically bad because it's not just an XSS on the client side that's worrying me, but also the fact that it is supposed to escape single and double quotes so that nothing bad will flow. Where is this? Where nothing bad will flow here. Okay, because now if this does not get escaped correctly, then someone else is able to escape this whole context and do whatever they want. Whatever they want looks something like this. Let's go back here and run. I'll shorten this a bit. So another way to represent HTTP parameters like this as an array is simply to push this kind of notation into the query param. So if I do this, like mobile, you could see the same functionality remained okay. But the moment I try to get a bit tricky with it, things get messy. And so if I just add a single quote, which as you can imagine with the Dust template that I had before, if I had a single quote, that I could actually mess the whole JavaScript statement. That's like a single quote that's like out of place in your own code. And so nothing will get compiled. And so if I do that, you could see again, like I send that request in, and what I get back is basically an unexpected string syntax error and telling me what is going on, right? So this is how we're going into the issue. Now, what I'll turn this into is not just an error on the application side that didn't know how to handle strings that it didn't expect. But at this point, I can actually exploit this vulnerability to be a remote code injection, or sorry, or I could actually inject some code to the server side to run it. And because Node is server side, this is what will happen. So I will append to the mobile string, I'll close the single quote, which is what this single quote is for. I'll close it because then it creates something like that because the code already started a single quote, so I just need to close it. And I'll append to it a function call. I can append any function call I want, but because I want to show you that this actually works, I'll do a console log. Where is that? Console log. And I'll append this back to the rest of the statement, and I'll close it because if you remember, if something got opened, it needs to get closed. So like the whole syntax is now, the whole line of code in my template is syntactically correct, and there's no syntax issues with it. So if I run it, it just works, meaning I just got the web page back. I assume maybe as mobile, or I don't know, at least not desktop. So that works. But what is the implication of running this console log 1? Well, we just said that this is all getting evaluated server-side on Node.js. So if I go back here, I now see that all of those log requests were now followed by this syntax error that we tried before. But not just that, but our recent log request of mobile and console log 1 really called console log on the server side. And that caused real-time code evaluation on the server side. Okay, so these are the dangers of essentially having code injection vulnerabilities in Node. You could find, if you want to learn more about this one, you could find this with with Dust. And like this version that I have looks like it has several issues like prototype pollution vulnerabilities. And this is the code injection that we were, showing you how that works. Of course, I can fix it. I can just click on this button, which I have manually set up so I can click on it. But for normal applications, hopefully if you use Snyk or something like that, you have all of this automation set up. So if there's like a new vulnerability, what will happen is a pull request will get created. You could see it kind of tells me I have this warning signs because this specific version is only fixed, vulnerability is only fixed in a new major version. So it kind of tells me as a developer, like, watch out, this could be a breaking change. But this specifically doesn't. So if I want to fix that vulnerability, I can just click on open a fix PR. And hopefully the Snyk app thing will actually open a pull request to my repository that just upgrades it to like the next fixed version. So with that said, and this kind of like happening in the background here, I'll get to that in a second. That was fun. Even though we had some, I think, technical difficulties, that was fun. We just had received now this pull request to my fork of the Goof app repository. It changed a few things. It even relocked my lock file because I'm using a lock file because that's a secure way of doing things. And it upgraded the minor version of my Dust.js LinkedIn dependency in my application and told me a bunch of other stuff that might be interesting. And all that I need to do is to basically mitigate its vulnerability is simply merge it, and that's it. This is how easy it is. Imagine when those things are automated and you don't even need to press a button, how easy that is. So hopefully this was like, a lot of fun for you all. If you have any questions, again, this is like a really great time. I'm just gonna basically run through some stuff here. We talked a lot about the dependencies and the larger attack surface, right? And that's kind of, we won't go into like the nitty-gritty details here, but I really just want to let you know that there's like a bigger attack surface that you should be aware of. And that is my repository also has other things, like it has my Docker file, which may have potential, outdated images, vulnerabilities in the Node image, Java image, whatever I'm using, because it's using open source libraries, because maybe the runtime is vulnerable, because a bunch of stuff. So, if you can import all of it and have all of it in a single view and able to mitigate all of those things, that's pretty cool. So this is an issue that you should be aware of. So what we've learned so far, right? We've looked at our application and we understood that the application itself is not just the code that we write. It's actually all of those libraries that we actually bring in that help us build the application. And that's amazing because that's open source. You just need to be a little bit, more careful in terms of being able to understand the risks, mitigate them, upgrade, as fast as we can when issues are arising, and just being up to date in general with open source packages. The other thing that we learned is it's not just the application code and the dependencies. We've just learned that, hey, look, there's like a runtime, there's like a container runtime thing, because my application might end up, if it's a backend, getting containerized, being built as a Docker image and pushed somewhere, deployed into a registry like Docker Hub, which then deploys, gets images to deploy them into cloud instances on like Amazon, like AWS, Google Compute, and all of those kind of things. So my attack surface is actually a bit bigger than just my application and my container runtime potentially. Well, let's understand a little bit deeper why it's that. Because my container runtime has all of those libraries, like we said, when we do from Node or from Oracle JVM kind of stuff, from Ruby, from Python, those base images to build container runtimes actually contain a lot of open source packages in them. So I can scan them with something like Docker scan, and potentially I will find an amount of vulnerabilities which I want to fix. And it sounds like, hey, it's just like image magic. It's just like Git binary or stuff like that. But who knows if that gets called or not as part of the application logic, or if something is able to trigger it. In fact, this specific issue that I just showed you of like not the demos, but the site itself of like image magic, now it has improper input validation vulnerability that I could show you a case where it's being used in one of like the Google I/O kind of like demos back then in 2017. So it's actually a use case of a container and a Node.js app converting images based on the fact that they rely on binaries existing in the container image. When that happens and there are vulnerabilities there, that's when things get, could potentially get a little bit messy, and we need to be very aware of that. And this is all application logic. So let's go back into what we just said. We just said there's like dependencies and container runtime and Apparently there's more. Yes, yes, what else? Apparently there's this thing called infrastructure where we need to deploy it to. And what do you know? Infrastructure is not just, plain old bare metal servers. It has been abstracted as a software. I can actually define clouds and clouds of machines uh, um, just using code, right? YAML or whatever else. And it's not actually a new concept, right? Because if you're doing front-end development, you probably use Netlify or Vercel. If you're doing, Kubernetes or just Docker, doing Docker Compose. If you're on the Google cloud kind of thing, you might be using Firebase. All of those kind of things are cloud-native application development methodologies and tools that help you abstract the entire infrastructure that your app or whatever resources you need using configuration, using code. And when you do that, there's a potential issue of you having misconfiguration and having opening different ports, allowing different escalation of unprivileged of privileged users into taking over the system itself. So there are a lot of things that actually get wrong here. So do you see where I'm going? Right, this is over continually expanding kind of like responsibilities of security around application development that doesn't stop with the code that we write or the dependencies of the container. It even extends to the infrastructure itself. Potentially, who knows what's next, right? More and more. So what is next, but for you? Okay, I'm gonna put some resources that we've worked on building, and I would be happy to share them with you. So if you are getting into the world of containerization, you're building Node.js applications, and you want to know what are the best practices of how to build production grade applications using Node and making sure that image is secure, I highly recommend going through this cheat sheet on the Snyk website. You could just Google this and you'll find this. It even made it and got accepted to be an official OWASP cheat sheet entry. So this has been highly created, and I really suggest that you follow those best practices to make sure that you're not building, potentially vulnerable and bad images that would have security issues in them. I'm also, if you're completely interested in the space, very broadly of Node.js security, I'm also maintaining this repository. You can find it. Stories of incidents and what happened and post-mortems, some tools that help you out, maybe some resources of learning and doing some stuff. So this is kind of an all over the place repository if you just want to follow what's happening in the Node.js security scene and space. If you enjoyed any of the stuff and it made sense for you to try one of the Snyk tool stuff, this is free for open source. It's even free for private repositories. If you are a company, you can still use Snyk. It's free to just to use it. It has a broad way of tooling, from the CLI kind of tooling to the app that I showed you to actually a VS Code IDE extension that is very cool. And you could use that both to find open source dependencies issues, as well as issues in your own code, like you may be having NoSQL injection issues, like I showed you in that very first slide with Express middleware and MongoDB. So that's really cool. And I highly suggest checking this out too. And finally, we've recently launched at Snyk this other learning resource called Join.Snyk.io, which is, as it says, I mean, I'm going to steal the title. It's as simple as that, right? It says security education designed for developers, because it's so, bite-sized kind of learning experiences. You could go in, choose a language, and just dive into learning some security for free. This is all just available for you to scale up. You don't even need a Snyk account. This is just for you to learn and get some experience. So with that said, I kind of want to give you one more resource and a hint for something that's happening now. Let me get into my browser back again here. So not sure if you've heard about this thing happening, but we've just launched at Snyk this thing called the Big Fix. It's actually been up for it's a month-long event. This we call it the Big Fix, and this is really all about us trying to celebrate security wins with all of you. So if you're a developer, you want to scan open source packages or your projects and basically fix the issues that we have in there, we will be very thankful for you to helping us shape a better, safer, secure kind of ecosystem for everyone in your applications. We've hit some really interesting and good numbers in terms of the amount of vulnerabilities and people just joining us. And oh, by the way, if you just take part and find and fix a vulnerability, you're gonna get a Snyk t-shirt, which is pretty cool. It's this purple t-shirt, actually very much designed for the event. There's a bunch of stuff here which I would not want to take all the time here, but I just want to say this one because it's important. You have to actually sign up here for, it's not enough that you get like a sneak account. You actually have to sign up here so we can match the records of you fixing vulnerabilities and attribute them really for you in your account. So put the email that you're signing up with Sneak for here, just submit it, and like that's it. We have a live stream with the agenda going to be announced pretty soon, but a 24 hours live stream, so all over the world on the 25th. So you could join us on the Discord, join on the live stream, do a live screen share stuff, and we'll be happy to help you out with anything. So with that, I'll definitely go ahead and summarize. I know we're kind of at time. I want to say, thank you everyone for joining. Thank you, Moria and Eve, for just enabling this. And thank you so much for all of your time and patience. This is me signing out.
Thank you so much, Ira. This has been a really good session. Eve had a meeting, so she'd like to send her regards. And thank you for doing this. We've learned a lot on the vulnerabilities and the best practices, and thank you for giving us solutions and resources. So I can say this has been a really good session. Thank you again. I see Laura in the chat. Laura, would you like to say a few things?
Yeah, of course. Maria, I don't know if you can hear me.
We can.
Thank you so much, Liran. This was definitely a very good session, and I'm very sure like the members have learned a lot. And I really look forward to interacting with you more. And anyone, if you have questions, Liran has left his details. You can see his Twitter. Please reach out to him. I'm sure he'll be able to help. Thank you so much.
Thank you all. It's my pleasure. All right, everyone. Bye-bye.
Okay, good night, everyone.
Good night. Thank you to everyone who attended. Thank you for giving your time this evening. It's like hugely appreciated. Good night. Bye.